This video is about Factorial ANOVA. In Factorial ANOVA, we are doing a really similar task to what we were doing with the one-way ANOVA, except now, as you can see here, there are two or more independent variables or grouping variables. Now we're still limited to one outcome variable, but we can have more than one grouping variable. Alright, so if we look at an example here, of course I always have my pens that give me trouble, so let's see. I'll draw a little example. Alright, so thinking about looking at our independent variables. Before we had one, and then we would have an outcome over here of some type. So if we think back to class, and one of the examples we had was looking at different, we can call this community reading. So these were three types of community reading programs or initiatives. So say we have a maybe library based, maybe community center based, and then maybe another type that's just out in the public, like at the example of the barbershop reading programs. So we have three types of community reading, and our outcome was library circulation. So the related libraries to the different programs, we wanted to take a measure of their circulation. So did the number of books that were checked out or other measures of circulation, how did they look when the community was engaged in one or more types of reading programs? And you know, it actually might be interesting if we included a fourth group, which would be no reading program or something like that. So this would be a one-way ANOVA, and the one-way has 4 levels. With Factorial ANOVA, what we're doing is now we're adding another independent variable. So we think for some reason there's another independent variable that's impacting the library circulation and also interacting with the community reading program. So it could be something like length of time, length of intervention. So maybe this is and I could again add my other category down here. So maybe this is 0 years, maybe this is 1 to 2 years, and maybe this is more than 2 years in which it's been in place. Alright, so now we have what we call a factorial ANOVA because we've added an independent variable, but like I said, we're still limited to one outcome or one dependent variable. So in this case, we would have we look at this as a two-way, so we have two independent variables, and then we put the number of levels. So this would be, for example, a 4 by 3-way Factorial ANOVA. Alright, it's a two-way 4 by 3 Factorial ANOVA. So you might hear it this way, 4 by 3 Factorial ANOVA. You might hear it described as simply a two-way ANOVA or a two-way Factorial ANOVA. But probably one of these two will be the most common. Alright, now thinking about types of questions, and we were talking about that really you can use a Factorial ANOVA in any of these research designs and others. You could use it in survey research, correlational research, Well, just remember that causal comparative is when you have existing data. Right, so this would be an example of the ECLS data that I'm interested in, the early childhood data. And so I might have, and I did have, a variable that looked at, an independent variable that looked at year of birth. And so it was like 04 and 02. And then I have this outcome of executive function. Alright, and that's my dependent variable. Okay, but to make it a factorial ANOVA, I need to have at least one other independent variable. So say I think, based on my research, that executive function is not only impacted by the year of your birth, meaning that kids who started kindergarten at a younger age versus an older age, there we will see some differences in executive function. And so an additional independent variable I might feel is home type, let's say. So maybe they live with a single parent, or maybe they have, let's see if I can get it to not erase, a single parent, maybe both parents, and then other. Maybe the other is like a grandparent or a foster care adoption situation, or maybe an aunt and uncle, that type of thing. But single parent, both parents, and other, I felt like was also impacting or interacting with the age at which they started kindergarten based on year of birth, and then together these influencing executive function. So this would be an example of causal comparative using existing data to look at this relationship. And so here we have again a two-way ANOVA, and we would have it 2 by 3 factorial ANOVA, or just a two-way ANOVA. Alright, quasi-experimental, same kind of deal, except if you remember here, we do have an intervention. Alright, but we could still use, and we would use for factorial ANOVA, the same type of a design. We would have more than one independent variable. And I'm just using the example of 2, but you could certainly have more than 2 independent variables. You know, so whatever those grouping variables are, and then you're still limited to that one dependent variable, whatever it is. Alright, but the difference between quasi-experimental and experimental, so remember that experimental also has an intervention, but up here in quasi, we have no what? You remember? Randomization. No randomization, no random selection or random assignment. But in experimental, we have an intervention, and then we also have this idea of randomization. Randomization. As you can see, I still don't have my computer that I can write on the screen, so you just have to bear with me a little bit longer with my chicken scratch. So, but anyway, just a look at how you could do it. And like I said, you could definitely have a correlational design. You could have, you could do a factorial ANOVA using survey research data you've collected. So these are just 3 of the what we think of typically the kind of the big 5 in quantitative. I think that's it on that one. So the good news is the assumptions are the same as what we had in the one-way ANOVA. Normality, homogeneity of variances, independent observation, and dependent variable on an interval scale. So there's not anything new you have to worry about there. Yeah, click at that. Okay. So we'll go over those again when we go through the practice. The effects excuse me, the effect size for Factorial ANOVA is the same as we had with the one-way ANOVA, except the difference we're going to encounter, well, a couple differences. First, this is produced by SPSS. So before, with the one-way ANOVA, we had to get the sum of squares and divide it ourselves. But now that we're switching to a little bit of a different command in SPSS, we are able to click a button and have SPSS add that to our tables. The second difference is what we had calculated before, this eta squared. This was more your classical eta squared or your traditional eta squared. What SPSS is going to give us is what's called partial eta squared, and it's going to have a little p for the symbol there, and so this is partial. Now, partial, that's an AL, TIAL. Sorry, it came out kind of weird. But partial eta squared is very similar, and it's absolutely interpreted the same way as the eta squared, but the calculation is a little different. And because it's a little different, the partial eta squared values are going to be inflated compared to what you would expect from the traditional eta squared. So what it's important to do, it doesn't mean a whole lot for us, except we always want to make sure and indicate that this is partial eta squared, because we don't want to give the reader the idea that it's this traditional eta squared when really it's partial eta squared. And anybody with kind of a background will understand that, oh, okay, well, these might be a little bit inflated because of the way they're calculated. All right. The last thing I want to bring to your attention is we're going to have an effect size for each main effect and the interaction effect. All right, so if I think back to our first example, I'm going to have a main effect of, I'm just going to abbreviate, reading program. I'm going to have a main effect of length of program, and then I'm going to have this interaction between length of program and type of reading program. So the results I report for both the effect size but also for the inferential result are going to be three. Main effect, interaction effect. And we'll look at this whenever we do an example. But when you're selecting independent variables, this kind of brings up an important point about variable selection. So say we had, what if we had gender, ethnicity, and SES. Maybe we said free and reduced lunch or not. Oops, that's supposed to be an S. All right, if I have these three independent variables, so this would be a 2 by, let's say we're doing 4 ethnicities by 2 SES, because this is free and reduced or not, and then we pick out 4 ethnicities we're interested in, or that we can measure. And then gender, of course, we just have the 2, the male and the female, right? For us, we're just going to do 2, male and female. Okay, so we have a 2 by 4 by 2 ANOVA, or a 3-way Factorial ANOVA, however you want to describe it. But when we add that independent variable, now when I'm interpreting, let's say this is for inferential plus effect size. We have the main effect of gender, we have the main effect of ethnicity, we have the main effect of SES, and now we've got to do all our interaction effects. So we're going to have, I don't know why I did an S first, so we'll do SES times ethnicity, SES times gender, then we have ethnicity times gender, And then what are we missing? We've got SES and ethnicity, SES and gender, ethnicity and gender. Is that it? Are those all the combinations? And then we have to have our full combination of ethnicity times gender times SES, right? So we would have our inferential result, and so that's going to be like your F and your degrees of freedom, and that equals that, and then your p-value. Remember all that? That's all your inferential for 1, 2, 3, 4, 5, 6, 7 results. Then you'll have your effect size for 1, 2, 3, 4, 5, 6, 7 results. So whereas over here in this situation, when we only had 2 independent variables, our interpretation is a little simpler. When we move to 3 or 4 or 5 independent variables, you can see how interpretation is going to increase in complexity. Now that doesn't mean you shouldn't do it or it shouldn't be done, but just be aware when you begin to interpret, it's going to be a little more complicated, a little more labor intensive, which is fine if that's what you need. And you also want to make sure that you have people in all of these cells, we'll call them. And what I mean there is, say for example, one of your ethnicities is Hawaiian Pacific Islander, and for whatever reason in the particular data set you're looking, you don't have any Asian or Pacific Islanders. Well, then that's going to cause a problem for your analysis, because this cell, if you want to think about it that way, is going to have zeros in it because you don't have any. So we want to make sure we have people in every cell. Or say when you, what about if you crossed one of these and found out there wouldn't be any males with a non-free and reduced lunch? Right, now you had females in the no free and reduced lunch, so at first you didn't notice that you'd have some empty cells, but now when you cross it with gender, you realize, oh no, I don't have any males in my no free and reduced lunch. So that's going to cause a problem for this interaction. Okay, so just think about, make sure you have people in every category, but then also when you start to cross them, make sure you'll have participants in each category. Alright, now that doesn't mean you have to throw that out, but it might mean we have to recode something or recategorize something into a different type of grouping. Okay, so the next thing we'll do is switch to SPSS and run and look at the output for a set of data I have. Okay, but I'm going to stop this video now, record that in a separate